All right, welcome to another session of San Francisco Dynamo User Group. I believe that because of the rain, the group is small, but thank you for coming, those who attended. Welcome. Yeah, have a seat. Again, follow us on our blog and Twitter, and if you have something interesting to say and present to the group, email us at sfdugcoordinator@gmail.com. I'm going to start with a couple of announcements. Happy New Year, everybody. 2017 starts with 2 great presentations, and we hope to have this same consistent quality of presentation throughout the next year, and thank you for your support and continued attendance. Today we're going to have a quick review of Dynamo at Autodesk University 2016. We are hosting this meeting at Rutherford and Chekene, and Dago, Delarosa, engineer in this office, is going to present, along with myself, a quick summary of what were the things of Dynamo that caught our attention and our take on the Dynamo front. And we're pleased to host Marcello Sgambelluri. Marcello is connected remotely from LA. He is the BIM director of John Martin and Associates, and he's a well-renowned speaker at AU and international events. Welcome, Marcello, and thank you for taking time to present in our group.
You're welcome. Thank you for having me.
Yep. Thank you to our sponsor in 2016, ID80 Inc., and we have renewed our sponsorship for 2017, so we will continue to have a flow of food and drinks for the next 3 years. If you want to talk to us or present something, that's our email on the screen. And the next month, the meeting is going to be hosted by Woods Bagot. We have 2 great speakers. Tobias Hathorn from Autodesk is going to talk about the integration of Dynamo and Format, which is one of the latest features of Format. And Behan, a programmer for Because We Can in Oakland, is going to give us a C# introduction for Dynamo users. So I'm looking forward to that one as well. So stay tuned for the announcements. It's going to be the second Wednesday of February, and we're going to try to do a better job on sending the announcement in advance. Great. So let's get on board. Let's talk about Dynamo of Autodesk University, and I'll start by doing a quick review of the classes I attended and the things that were important for me. And with me, sitting next to me, is Dago Delarosa. Dago, if you want to introduce yourself.
Okay. Hi, my name is Dago Delarosa. I'm an engineer here at this office. And
he's a Dynamo fan.
Yes, I am.
And worked as a structural engineer here as well. Okay, so probably more than half of the Dynamo team traveled to Autodesk University, and it was record-breaking. It displayed more than 50 classes related to Dynamo workflow, and the popularity of Dynamo seems to suggest that is no longer something that is seen as a standalone software. It's technically integrated with a wide range of practices across board in the AEC industry. So my impression is that the tool is getting a level of maturity very close to the one of Grasshopper at this time. There are 2 feature events that we're going to focus on. One was the 8th Design Computational Symposium, which was featured on Wednesday, and it was a 3-hour workshop featuring different speakers from across academia, practitioners, and educators. And some of us attended as well the computational design workshop, and there were two variations for this year. There was the beginner course with the display two courses running simultaneously, and then there was an advanced computational design workshop for the first time, which myself and Dago attended for an entire day on the Monday before the event, a pre-conference event. I'm going to talk about the Design Computational Symposium, and this was a 3-hour presentation panel discussion of really great speakers. We had an opening remarks by Phil Bernstein, a quick note about the future of making things. Valentin Hune presenting the reality editor. It was a take up on how computational design is affecting the way we capture reality and present reality in our documentation. Fred Martin with the App Inventor, and Max Oglesby with Creating a Responsive Civic. All of them are a great presentation. All of these are recorded at Autodesk University website. And then the second part is the part I really like the most, I enjoy the most, part because these were real examples of how Dynamo is being used by true practitioners. Raja Issa is, if you heard of her, she's one of the writers of Rhino, and her presentation, Beats and Bytes in Architecture, was an explanation of her journey as an architect turned computational designer, which I thought was really appealing. Another great presentation with Marta Tizikari, and a review of the computational design work by Foster and Partners, and Ryan Welsh with the near future practices. Out of all this presentation, I'm just gonna highlight, 3 key speakers that really call my attention. Philip Bernstein. The image that you see in the background was the result of an exercise that demonstrated that generative design, it's already here. So he was speaking about this office project where, given a set of constraints, enable designers to create hundreds, if not thousands, of room distributions that meet all the criteria. And the criteria is outlined in here, given a predefined set of envelope boundaries. The idea of maximizing a view and daylight and respect employee preferences based on a survey generated, this set of hundreds of explorations that meet all the required constraints. And that in itself was like a wake-up call for me. I really like this diagram that he presented, in which he attempted to illustrate what are the current, present, and future trends in the ANC industry. And he was saying that the idea of optimization through computational design method is already here, and what's really going to happen in the next couple of years is to focus on the protocols for managing the decision making of evaluating a large amount of options. And there are 2 ways that he proposed to do this. One is doing smart analytics, another is using machine learning. And these 2 new trends, it's basically going to shift the way we do and produce the way we do buildings and artifacts, because the availability of infinite computing and infinite mass storage would enable us to produce the kind of algorithm to train machines to make decisions closer to the way humans do it. That was pretty compelling. Um, the other presentation that I really enjoyed was Raja Issa, and he explained her journey through the development of the paneling tools for Grasshopper. If you are a Grasshopper user, this is a set of plugins that you can download from Food for Rhino. And she explained, what was her idea behind enabling users with this idea of customizing and created points and diagrams and her journey from being a practitioner architect into somebody who was trying to solve design problems by generating new tools. She was demonstrated how the Grasshopper tool works and how it's being used in practice. And the image you see in the upper right side is the set of the Terminator Genesis movie, which was used using her set of tools. And her journey illustrated that a lot of us are not far from the same type of path. Choosing design technology and computational design as a way of exploring new professional paths of development. I think that's the right one. And the other really compelling presentation is the one by Martha Tizikari. She was given a presentation on the technical aspect of creating the Mexico City airport and this massive amount of computation resources required to produce the canopy that sits on top of the new airport. She showed snippets of the code, and she was mentioning that it took about 4,500 nodes and 127 custom C# scripts to get this done. And because of limitation of the software, the structure couldn't be created in a single model. It has to be broken down in 50 different zones, and each of the zones needed to be transformed for documentation purposes into Revit. And they used an integration of Grasshopper, Rhino, Dynamo, and Revit for the documentation. And she explained the process of optimizing the facade via an analysis of dynamic relaxation and the different interactions needed to create that structure. And the upper right side, you see how they translate the geometry into the Revit file for documentation purposes. So it was pretty compelling, pretty amazing. The bottom line was that the tools available for designers are in our fingertips, but the level of sophistication needed to get something done required a high level of programming skills. And this was her one of the comments she had, that engaging in an exercise like this required a dedicated group of full programmers, and that level of skills is still far from a typical designer or architect user. So he was advocating for tools that facilitate that type of computational and require or ease the need of creating custom rules and custom nodes. Another presentation was by the one by Colin McCrone, and you can see that I was all about sitting in those classes related to panels and panel fabrication, and he explained a case study of the Jewel Jangi Airport, and what I found really compelling of his presentation is that all this rationalization took place using only design script. Like, he didn't went into custom Python or custom nodes. And on the screen you see how he made use of ranges and sequence syntaxes to assign zones within the facade structure for optimization purposes. And on the right side you see the row geometry and then the result after it's optimized. The recording it's available at AU website, and most important, his workflow is really very well documented in a PDF. So feel free to go and check it out and download it, because I think it's a great resource. I also attended Vegas is not Vegas without partying. So Dynamo has a after-hour party, which started actually at 9:30, and run all the way to 1. And everybody that is on design technology was there, probably about 10 people, 100 people, sorry. And they were showing this. This is the Dynamo Reel, which is a compilation of all the work that Dynamo user groups have done around the country and the world. I'm not going to run it all because of time. And we had time also to have fun. This is Dago at the Dynamo after party. And he held it pretty well. It was fun to see this in the middle of that party. Okay. Dago now is going to take a brief of the BIM Advanced Workshop. And
okay. So, I attended the Advanced Workshop, which was an all-day course, 8 hours. There was a workshop for Dynamo, also for beginner users, which what I hear was really, really good also. During our workshop, there were 6 topics that were covered. The 6th topic was, we ran out of time, so it wasn't very, very well covered, but the information is online, and I'll show you where to get the information after. This is the first topic that was talked about in the presentation. There were four presenters, and each one switched from one topic to the other topic. And now the first topic explained on what are case studies of how Dynamo has been used in the design field. There was another part where they explained what are the Dynamo packages that are available to us. You can see these down here. And then there was another bit on how to access references towards Dynamo. And second topic was a little more interesting. They were explaining what are lists, what are the different types of variables or data types that you can find within Dynamo. So you have your booleans, you have your strings, you have integers, you have numbers. There was also a talk on what is the difference between the var bracket, bracket, and there's this famous photograph which was published by C McCrone. There's a very nice blog post if you look, search online. And there was also an introduction into what are dictionaries. If you're not familiar with what is a dictionary, it's very, very similar to using a VLOOKUP within Excel. There was some talk into what is lacing, what is the difference between using shortest lacing, longest lacing, what is the cross-product lacing, and when you want to use each one of these. And then the most interesting part about this topic is the list at level. If most of you know that list at level is a new feature that popped into Dynamo version 1.2. And this is to replace the list.map node. And if you are interested in learning more about this, it was Zach Cron last month. He presented on this topic at the Dynamo user group for San Francisco. You can find the video and the notes on this on the SFDUG website. And the next two topics were hands-on examples or training. And in the left here, we have auditorium seating. We have a speaker down at the bottom, and then we are trying to orient all the chairs to face the speaker. And then based on where the speaker is, we can pull information out of the chairs and then manipulate that information and then feed it back into feed more information back into the chair family. And in this workshop, we were able to do this procedure using Dynamo. There was also another example where we brought in geometry created in Rhino using Dynamo to bring it into Revit. The next topic was on going beyond the node. So what happens when you need a node but the node does not exist, or sometimes it's just easier to write a code to process your information. So there was some talking to design scripts, defining functions, creating zero-touch nodes, and Python scripting, where the presenter gave us recommendations, do's and do nots for each one of these. And the last topic was T-splines and meshes. So meshing is something that's very, very useful to us engineers, as we all run into having at some point to mesh something, but it's also very useful for the architects. T-splines, they did not cover very much in depth. There is information on the class handouts. And T-splines, I think it is a new to Dynamo 1.2. Is that right? Okay. Now, if you are interested in any of these topics, you can find the class notes and the example graphs and Dynamo graphs and Revit files by logging into the package manager in Dynamo and searching this topic. Now, the next class that I attended was coding new nodes with Dynamo. And as I had previously said, that sometimes you require a node that does not exist. And also there are times where you are running a graph in Dynamo and it is taking a long time. So maybe by using coding options, you can write the same script, but it will run faster. And this presentation, we ran through creating, I think it was 6 different nodes using C#, and then exporting the code into Dynamo, and that way we could bring new functionality into our graphs. Now, the class notes I found were not very useful, but the Dynamo graphs, the code for writing the C# and the Revit files are posted online at the AU website. Now, the procedure for writing the C# is using Visual Studio, which is a free Microsoft download, and then you write a DLL file, and then you import that into Dynamo. There are 2 websites that I put on here, which are very useful references if you're trying to get into this. And I'm going to move on to the next class. The next class was 20 practical uses for Dynamo. Now, this was a very interesting class to myself. These 2 presenters down here, they presented 20 different graphs and how they can be applied to the architecture, construction, engineering workflows. Here's one example of how they wrote a graph that you can fill in an Excel spreadsheet with your sheet name, sheet numbers, your family that you are using for your title block, and then just by hitting the button, it creates a list of sheets in your Revit project. One thing that I do appreciate about this, it's when you look at it, it is nicely coded. Everything flows, and that was one of the topics that they also talked about is Dynamo graph organization. This is very important for when we are writing our graphs and we expect that somebody else will use it in the office. Well, we need to make this easy for the user, the next user, to be able to access the information and use it in a way that is efficient. So the next topic, and we can obtain this by using the grouping options, and then also by creating intelligent labels so that the next user knows what they are doing. And also, you want your graphs to flow. You want a logical path going from the beginning, from the user inputs to the final results. And next thing I want to talk about is this is a new program by Autodesk that I have been playing around with, Project Play. This was also showcased at AU University. It is a program for writing web development, but it can also be used for creating VR experiences. It is very similar to Dynamo in that it works off the Node and the string programming language. And let's see if I can get this to work. I will show you just a quick example of an experience. They have this website with different projects that have been created. And one that I find very interesting to our field is, let's say, this one. If it loads. Okay, so we are in this environment where we can rotate around. Let's say we want to find out information, or we want to move to a new location. We can go up the stairs. We can move back here, and let's say we can visualize different options. Let's say we want to change the color of this wall. We can play around with different options. And this can be created into a VR experience. All these environments are created in Revit and then exported out and then brought together with this program. Now, this program is in beta testing right now, so it's not available, but very soon it will be coming out into the market. It's something that I find will be useful to us. How did I go back to? Okay. And that is my presentation.
All right. Marcello, are you with us?
Yes, I'm here.
Okay. So let me introduce now Marcello. He's thanks for your patience, Marcello. He is here presenting the topic Dynamo for Structure. Marcello is director of John Martin and Associates, and he's going to share his later research on workflows related to practical application of Dynamo for structural uses. So, Marcello, I'm going to drag the controls to you and click the Share My Desktop button.
Okay.
It's perfect.
Can you see my screen?
Yeah. Yes. Yes, we do.
Can you see the 3D model?
Yes.
All right, I'll pop right into this thing. All right. Hello, everyone. How many people do we have there, Cesar?
About 10 people.
10 to 12. Okay. All right. Hello, everyone. I want to go to the process through the Dynamo structure. And I think you can apply on a basis. And I want to first talk about some of the advantages of the new release of Dynamo. And it's 1.2. So let's get started. I have a typical structural framing. And if we look at the floor plan, here's the structural beams, steel beams. They're not labeled, but you can see the structural beams in the floor plan and the slab edges. One thing that I struggled with is the fact that when you want to get beams to the edge of slab, so for example, if this needs to be 6 inches off the edge of slab, what you would normally do is you can do 6 inches like that, but if you have beams that are off and you need to align them, the problem with the align tool is the align tool basically aligns to an offset of 0, yeah? So if you were going to take this beam and you need it 6 inches off this edge, what you have to do first is click your align tool, grab the edge, grab the beam, and now you're at 0, and then you got to take your beam, yeah? And then you have to move it up off 10 inches. I guess this would be, 10 feet, I suppose. Right? And then now you're at 6 inches. Okay.
Got it.
Yeah, all right. That's fine, but there's no align offset. If you had an align offset, you could then rock through these really fast. So let me show you how to use Dynamo to do that. So if you go to Dynamo, open up a new one. What you can do, can you see my screen okay? You have a big screen over there?
Yes.
Cesar? Yeah, okay. Just let me know if the notes get too small, because I can't see the screen over there. All right, first thing we want to do is we want to be able to use the new functionality in Revit. It's really cool. So I'm using, yeah, I am using 1.2. I'm actually using a data build, but if you're not on 1.2 yet, get on 1.2. There's some cool stuff in there. A lot of new Revit functionality. And just a side note, if you can't tell what's new, if you go to any of the, in the Revit tab, you can go to Elements, and in Elements, if you click on some of these categories, Elements, under Element, or that's not a good example. Anything that doesn't have a defined icon yet is actually a new function. And the actual new function we're going to use is this one called Set Location. This one's really cool. Because set location allows you to feed in an element and then any geometry, and it'll set an element to that location. So our plan is to take the beam element and set its location to the edge of this beam, but at an offset of 6 inches. Watch out, it's pretty quick. So what we do is rotate our. So you can hear me okay, Cesar?
Yeah, it fluctuates. But
it's flopping around, but okay, even if you don't hear me, you're going to do it.
okay.
Yeah, right. What about the time level? We got to still in the sheet. All right, so let's see there. Okay, so what we want to do is we want to select the edge of the slab. There. We want to select the beam. There's all a different selection methods. So for this, I use select edge and select model element. That's the beam. Okay. Then the slab edge actually already comes in as a curve. Let's see if I zoom to fit. You see this curve? That came from the slab edge. That's already a curve. And then we don't want that location because that's at 0. So we can actually do an offset. So if we go to geometry and then curve, and we cruise over to offset, you see here it gives us a curve and a distance. We can feed in the curve, and the distance, again, is default 1 foot, because we're using feet as units in Revit. So I could say 0.5 is 6 inches, so 0.5 there. Okay, and then I have the offset of 6 inches from the original location. And all I do is I take the element that I want to move, which is the beam, and then I take the geometry I want to assign it. You see how it automatically aligned it?
Yep.
And so what I do is I turn this to annual, and I got my slab edge and I got my beam. And then I just start walking around everywhere I need the 6-inch offset. So here's another one. I'll select my edge, and then I'll select my beam. And then I'll hit run. Boom. See that? It's actually twice as fast as doing the align, offset, align, then move. So I can do this one too. Your edge, boom, and beam. And then run. What you could also do is you could set this up with Dynamo Party and have it simple. There are times when you take it negative input. For example, this side select this side edge and this you see how it went on the inside? Some offset put this as down constant. So what I do for those is also so I've got through and I this is of course is a really simple 4 node, 5 node way to do it. You could really use the application to a much more non-manual advantage where you could do your spatial analysis with a slab edge and all the beams around it and set it to an offset of 6 inches, you know, it's auto picking them before you, but I found this to be pretty quick and dirty. Hey, how's that? Does that help?
Yeah.
Okay, so you can use this on beams and walls and whatever else you may need to what you classically would use as an align and move scenario. Pretty simple. All right, let's move on. Okay, what I got next is, let's see, close that. And what I got next, so that's the line offset. And by the way, I'll have this data set available for you, Cesar, so you could share it with the group there.
That's fantastic. Thank you.
Yeah, absolutely. Next, let's talk about beam placement. I love talking about beam placement. Okay, so right, so mostly for roof framing, when you lay out structural beams, the frustration I always have is current beam model controls is a piece of garbage. It's about 14 years old, maybe 16 years old now, maybe 17. You could argue it's 17 years old, but it has a lot of limitations. So, for example, if I wanted to put a beam from this girder to this girder, the only thickness option I have right now is I can put the center point to the center point of this, or the midpoint of this beam that's actually curved in elevation. That's the only option I get. If I want to place a beam along a quarter point along the arc length, there's really no good way of doing that right now. In fact, I'm not even sure how to do it, Cesar. I suppose you'd have to take a section cut, put it in elevation, maybe do an array and assume a quarter point. But what I found is the problem with the beam tool is these ends of the beams aren't very smart. They don't really snap. They don't snap. They snap to the beam, but they're not very intelligent. So you can't take over the quarter point. You only get the midpoint or the third point. I mean, you don't get the third point. You only get the midpoint and so on. So they're not very intelligent, which really bothers me. But one thing that is intelligent with smart ends is actually an adaptive component, a 2-point adaptive component. So if I make 2-point, I have one already made. But basically, a 2-point adaptive component just looks like this. It's basically a line with 2 points on them. And they're really easy to make. You just take a model line, and you just put 2 points on the end of it, or you take a spline 2 points and 2 points, you click the 2 ends, and you say, make adaptive. And that's really it. You can then rename it and send it into your project. And these points can be anywhere. Because the whole point of an adaptive point is that it wants to host onto something, so it doesn't matter about its original shape. Okay, so I already made one here. Yeah? What's really beautiful about the adaptive line is that it's able to host onto structure or really anything. So I can take which would represent the center line. Place it here. Here. Let me turn on hidden line too, that would help. Oh, let's hope I don't crash. Oh, I crashed. I might have crashed. Without the, okay. I'm having stability issues with my computer right now. Oh, it won't let me, that's interesting. Oh, there we go. That is so weird. I'm not getting it allow me to turn, okay, whatever. Not letting me go to hidden view. I don't know. Okay, so let's do that again. Well, we just don't do hidden view. So there, and then up to here. Okay. That's the center line. And you see how you can control that point by location? Point 2, we go point 25 along quarter point. Yeah, and then what you could do is then take your beam through your snap and then just snap it on. Or you could do that. Yeah. And place all your beams. And then come over here and do 3D snap. So first of all, that's a huge time saver when you want to smooth framing. I find it to be extremely powerful. But if you don't want to do the beam, okay, is that a little better?
Yeah.
Not really, huh? Okay, I'll try to yell because my level keeps up. But anyway, all right, you can follow me with any case, I think.
Yes.
All right. So now that we have these in place, you can actually use Dynamo to set them. So you can go, you can select the whole first, all of the actual families. So we could do select family type, and then we can find it. I actually named it this one 2 point. But what I typically do is I'll name them the actual beam size, so it's W16 to 26 and so on. And you can select all the types to this. Okay, so now I have these two selected. And the thing, a hint is you don't have to use a watch node anymore. You could just type in a variable and basically have a watch node. So that's how I do my watch nodes. I don't actually use watch nodes anymore. Hopefully you can hear me.
Yeah.
Yeah? Mm-hmm. Yeah, it's kind of old school. It's kind of old school to me. So I just drop in the variable and then type in, and that's my watch node. I suppose you can type in watch if you wanted to. Yeah, make yourself feel better. Like that. Okay, so anyway, we got two. All right, so what we want to do is we want to actually place the beam on it. So what we do is we go over here to element. And then we go to structural framing. Structural framing beam by curve. Which is right here. Okay. We want to see it in a curve level. So what we do is we go to the selection again. And the level really doesn't matter because we're framing in 3D, they're not flat. So you can pick any level you want. And then structural framing, you're just picking the type. That could be any type, I suppose. We'll just pick a type like that. And then the actual curve, the actual curve that you want is something you extract from the family. So here's the family. So to do that, all you do is come over here to elements, and then you go to element again, and then under that you say curve. This will pull all the curves out of the family. You see that in? And then you see we're showing the curve. You take that and include it into the curve, and you see it sets the beam. Okay? So what's really cool now is you can take your adaptive, and then you can continue to frame whatever you want. Continually track anything you place. And I use this all the time, especially for kickers, that kind of thing. And when you exit the command, it automatically exits a step. And what's really cool too is if you move the adaptive line for any reason, you can minimize Dynamo now. It will automatically track the location of the move, see? Like
Yeah.
that. Yeah, there you go. Okay, so that's really helpful. So quite honestly, I don't lay out structural framing anymore using conventional beam framing. I will lay out adaptive components like this, and I'll make sure all my work lines are correct. And then after I get that all set up, I'll take that on, and then I'll place on the beam. Alright?
Good.
Can you still hear me?
Yes.
Yeah.
Quick question.
Yeah.
Any ramification of having the adaptive component in a different category? Or is that not a really issue?
You know what I tend to do is I'll tend to put the adaptive component in a category that is something that we never use. Usually planting or something else. And then I'll just hide that entire, I'll just hide that category in my project.
Got it.
Or, I mean, if you're completely done with them, you could even delete them if you wanted to. You know? It's more of a guide to help you. But I haven't seen any, it hasn't been an issue. The time savings here is incredible. Okay, next, I want to talk about more beam placement and being able to use, let's see. Okay, so let's talk about, I got to get back there now. Let's see. Canopy frame. Okay. So some complex framing and curved surfaces. Dynamo is very helpful for this. So for example, if you have a surface like this, then you need to place structural beams that follow the surface. Yeah. So let's talk about first floor. If you want to place beams along grid C. This is the surface that you see, yeah? But there's no way to actually place a beam on here. Take a structural beam. You're not allowed to use your pick tool, and you can't pick this, even though Revit is cutting through this surface and you can't see it. So basically what you need is this line in order to place the beam on. But that line is really a result of so here's grid C along these columns. What that line is really an intersection of this surface. Let me turn off shading. Why is shading on? Or shadows, excuse me. This surface and a plane, which is grid C. So all we need to do is extract that two pieces of geometry and we can do it. So let's go back to this one. So let's go ahead and use Dynamo again. So we go Revit. Keep forgetting Dynamos now and Manage in 2017. All right. So Cesar, you can hear me okay now?
Yes.
Awesome. Okay. So we're going to go new. All right. So what we want to do is we want to be able to select. Actually, let's go ahead and put it on every grid line. 1, 2, 3, 4. Isolate. Now, it doesn't have to be grid lines. It could be arbitrary lines that you place, but grid lines are most convenient, usually for girders, that kind of thing, at least starting for it. So let's go and put those big, beefy girders that would be there. So let's go and select these 4. So we'll say selection. I'll do model elements. Select model elements this time because there's more than one. Like that. Now I have 4. Now grid lines are a little special. We need to actually extract the curve. So let me put down right now, what I typically do when I model anything in Revit from Dynamo is what I'll typically do is put down that element first so I know what I need to fill with it. So for example, if I'm going to do structural framing, by curve, I'm going to put this node down first. So I know I need a curve, a level, and structural framing. So this curve, like I mentioned, is going to be the intersection of that surface and my grid plane, the plane of the grid. So I need to first turn the grids into planes, so I need to first select the curves of these grids, because Dynamo has no idea what, these are curves. Excuse me, these are Revit grids that I selected. So Dynamo has no idea what Revit grids are. They gotta convert them into Revit geometry. But grids are special because they've got grids, they've got extents, and they've got bubbles, and they've got text. So they're real complicated. So in order to extract this curve line, you wouldn't normally do the typical curve extraction. You would say elements, and then you would go under grid. It's similar to a beam, and then you'd say curve. And it says get the underlying curve geometry of this element. It should say of grid because this is all specific to grid, but anyway. So we can go like this, and then it will actually extract the line. But if they were curved, then it would be a curve, okay? So that's cool. The next thing we can do is actually get that surface that is the roof surface, or the underlying mass that would support a roof surface, yeah? Because you could have a roof and pick the face. Okay, I'm jumping ahead. All right, so then let's select that. So we go Revit, selection, and then select face. I'm using select face. There's only one face here, but sometimes you'll have a roof, a curved roof, solid element, and you need to select the underside of it, for example, and then select face works for it. And it will automatically extract a surface. So you see now where I have the roof surface, or the rig of the surface of the roof, the underside, and now we have the curves. So all we need to do is then extrude these curves up so that they become planes. So the way I do that is I take the grid, curve now, and then I'll go to, now that I'm working with Revit Dynamo geometry, I'll then go to curve, and then under curve I'll say extrude here. Extrude curve, direction, which is vector up by default, and distance, which is 1 foot. So I'll feed the curve in, you can see they're extruding. But this distance probably is going to be like, I don't know, 15, 20 feet. It doesn't really matter, just as long as it's past the surface, yeah? So now all we need to do is run an intersection between those planes and that surface, and we've got our curves to feed in, to place our beams on. So all we do is run an intersect. So we go your geometry, then geometry again, and then one of my favorite nodes in Dynamo is this grid intersect. The reason I like this so much is because Revit doesn't have a geometry intersect. If it did, then we wouldn't be going through all of this, yeah? Doesn't actually, you don't have an equivalent function like this in Revit. Well, I suppose you could argue that placing grids on surfaces, if you divide them, you could do that with reference planes, but anyway, not just with any element. Okay, so now we have the surface, we have the face, which will be our geometry, and then our surfaces, and then we'll do that intersect. And why didn't it work? Oh, okay. Because we have to apply it to the entire list. So we're going to turn our lacing to, in this case, could be longest or cross, either one actually, because we're only feeding in one here. And then now we've got all of our curves. So if I turn that off, you can see them on there, right? That's golden. That's beautiful. Oh, that's pretty to me, quite honestly. All right, so now we got a curve. So let's just rock and roll again. We got Revit. Now we have to put in levels. We got, let's see, where's levels? Levels, and we got structural framing types now. Because this framing is not horizontal, it doesn't really matter what level you pick. I quite honestly like to put my roof framing on level 1, because if I do that, then I can read the output on each end, and I know it's relative to level 1, and I'm actually reading like a top of steel value. So instead of reading off level, whatever roof would be, and it's maybe plus 2 feet, I'm reading it off level 0, and I know it's 57 feet, 2 inches or something. It's a good way to kind of back check the top of steel that I have to eventually document. So it's kind of something that I do. It's really helpful with roof framing. Okay, so we fed that in, and then all we need to do is feed this one in, right? The curves into, you can see these nerve curves, into framing. And now it should do its magic. Oh, here they are. There's a bug running right now that's been going on for a while. When you play structural framing and they're really complex, it flips the cross-section rotation to 1E. I don't know why. Developers are still working on it. But anyway, you see, now you have the beams that are actually following that curve, you see? This is super cool. And now, if there's any changes, it can be tracked with Dynamo. So for example, Dynamo is now tracking the grid location, so that now if you actually, let's see, how do we do this? Cesar, you're probably better at this than I am. Let's see, tile. Yeah, probably tile. Let me close this one. Tile again, maybe. Let's see. Tile. Yeah, here we go. Okay, so if we were to take this grid and move it in any way, see, this is grid C, then it should automatically update the beam, see? Or if grid B moved, somewhere, then it'll automatically change the framing. See? Cool, huh? Of course, the columns go with it because they're tied with the grid. All right. Any questions about that? Basically, just all you're doing is grabbing the surface, grabbing the grids, extruding them, running the intersect, and then on the intersect, that's what you're feeding into the structural framing. And then at this point, what you could do is then take over from the last example. I'm having trouble with these. These are kind of buggy down here. I don't know why. You could then do adaptive components and put straight members between here, right? If you wanted to. Typically, then I guess they could be curved, but if you had straight members running between here, you use this method to place the curve, and then to do the straight beams, you can do your adaptive component, and then boop, 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 and away you go. Yeah. That canopy framing could be framed out in the architecture office. Actually, you could frame it all up before you send it to your structural group.
Cool. I have a question. Will it work with curved grids?
Does it work with curved grids? Well, yes and no. It would work with curved grids in terms of getting the intersection. So you could get the curved grid. You could use grid curve, and it would extract a curve. Here it would say arc,
yes,
instead of line. And then you could do the extrusion and do the intersect. And you would see on here the blue line that would follow. But now that blue line's curving in two directions. It's curving in plan.
Yeah.
It would be, I was just kind of logically thinking about this, yeah? It'd be curving in plan, but then it would also be curving in elevation. So in that case, you'd have a compound curve. So if you were then to try to use this node, it would fail because you can't place structural beams that curve in two directions. But you wouldn't, that's a limitation, of course, of Revit, but you could use that intersect and place, you could do an extrusion and model a beam, you could do not an in-place, you could do you can make it another way. You can make it, what you could do, Cesar, is you could make it using Dynamo geometry, and then you could now use these new and improved nodes called, what am I thinking of? The new ones that bring the geometry back in. Why can't I think of that name at the moment? Oh my goodness.
Direct shape?
I'm sorry?
It's not direct shape?
Yeah, direct shape. Yes, direct shape. And then you can use this then to bring the geometry back in the structural framing category.
Got it.
You force but typically for structural framing, you wouldn't typically see beams that curve in two directions unless they're on edges and they're tubes, they're symmetrical shapes. These I-beams hate it when you twist. The other gentleman there, I'm sorry, what's your name? The one you did the code speaking?
Dago.
Is he still there?
Dago?
Yeah. The secondary stresses and bending a black wedge in two directions, and the amount of torsion resistance on an open section is just extremely small. So you'd want, if you were going to do something that bended in two directions, curved in two directions, you'd need a closed shape typically. But okay, enough of that. Any other questions? I use this method all the time, quite honestly. And another thing I do, I won't go into it. It was actually a separate example. Is you see these are grids, but they don't have to be grids. Just for example, what I do sometimes is in my floor plan, I will actually take my grids and if I have a curved roof, for example, I may actually lay out all my framing with model lines in plan, like this. I'm just, I'm running through this quickly, but just as an example, maybe the structural framing in plan looks like this, right? Just as an example, but it's truly flat when I model it. So you see that framing down there? It's flat. But I model it all flat because it actually looks the same in plan. But then what I'll do is I'll then use this same method, but instead of extruding grids, I'll extrude those model lines, and wherever they intersect, then it basically is projecting that framing onto the curved surface. Was I clear enough on that?
Yeah, that makes sense.
So I can go from flat framing to curved framing by just modeling it flat. And I'll typically do that in like schematic because in plan it looks the same. And then once I'm done with that, then I'll take all these, extrude them up, and then I'll get rid of the model lines, and then I'll have all the framing curved on the curved surface. Or I'll keep these in a work set that I'll then hide. And then if there's any changes, I can just make them to the model lines downstairs here, and then it'll just make the update. Or this is really not working here. Or if the roof surface changes, if this roof surface were to change, it's still tracking its geometry. Then it would then modify the framing accordingly. So just some other options there, yeah.
Yeah, great.
Okay, cool. Yeah, I can go on and on. Maybe let me do a tiny one real quick, and then we'll call it quits. Okay, so got that. Canopy framing. Let's talk about one more, which is surface area. Just kind of a quick practical one. A contractor asked me, so if you have a bunch of beams, a contractor asked me, is there any way to actually get the surface area off a wide flange so I can do my fireproofing takeoffs? And right now the Revit schedule won't do that. So you can use Dynamo. It's really simple. All you have to do is, let me turn that off. I'll start it again. Hey. There we go. Yeah, it's really easy. I'll go over it really quickly. In fact, I don't need to build it for you. I'll just show you open. I won't build it for you. I'll just explain it. Here's somewhere. Let's see. I have it all for you in your data set. Here's surface area. Okay. Right, here we go. Okay, so let's see. Let's start here. All right, so what we do is you basically, so here we go. You select all the families, and then you change them all to element solids. Okay, it'll extract all the solids. See it here in Dynamo? Then there's this beautiful node right here called solid area. It's under geometry, under solid, and then under solid, it's right here. See this area? Returns the surface area as sum of all areas of all faces. That's really powerful. Before I was actually taking all the faces and calculating surface areas, but this will do it for you. So once you have a solid, then you just use this solid area, and then it'll calculate the area of all the faces. Okay? And And by the way, I confirmed this with taking the one beam and then using the AISC manual and looking at the surface area. So I confirmed that this method is valid. It's off by about 1%, only because the way the AISC manual and the way Revit models the actual beam, they're just slightly different, ever so slightly different, but they're close enough. Okay, and then of course you just use the math sum. This is flattened only because you don't want individual lists. They have to be one list and then individual items in order to do the math sum. Okay, so that would actually be total 3,200 or so square feet of surface area of beams. Okay. Any questions about that? Pretty simple.
Yeah, I have a
I
question.
showed that to the contract. Yeah,
You wouldn't fireproof the top of that beam. Yeah,
you're right. Who asked that? That's an awesome question. Who asked that?
Dago, the other presenter.
Cool. No, that's an awesome question. Very valid. In that case, so this would work really good for columns, or you want a quick estimate on beams, but you're right. Rarely would you have a beam that would be, the top surface would be exposed. I suppose there's some rare cases, right? But usually have some kind of deck on top. That's correct, and it wouldn't be fireproof yet. That's correct. In that case, you wouldn't be able to use this. In that case, what you could do is you could then go back and do what I was telling you. I won't go through the whole thing, but you could then go to your actual geometry. And if you look here, there's something called faces. You could actually extract all the faces out of each of your families, and then it'll give you a list of a list, and this will be all the surfaces, all the faces of each beam. Then you would pull out, you would take this list and remove the top face, and then you would do. Luckily, faces or surfaces actually have an area as well. If you look under surface, if you look down here, it has an area. Returns total surface area. So then let's say you do this, you pull out the surface, you'd run that, and then you'd run the math sum. Does that answer your question?
It does.
A very good question. In fact, if I look at this list, I can tell you it's probably either 3 or no, I'm gonna get in trouble here, huh? Okay, let's see. No, this would be the web, right? So it'd probably either be 6 or 12, yeah?
Yep.
Yeah, okay. Cool, yeah, good. I love geeking out about this engineering stuff. Yeah. All right. Any other questions about that? Oh, one more thing. If you have these surfaces, you can actually use the thicken command, and you can thicken the faces, and then you can you could thicken the faces, and if you thicken the faces, you actually have simulated fireproofing. Yeah? And then you can send that back into the model under a different category, and it would be fireproofed. Does that make sense?
Yeah.
Yes. If you thicken these all outward, then that would be a thickness around, and you can use that as fireproofing. Yeah, pretty cool. I've done that before too. Okay, one more thing before we close is I want to warn everyone about this. Okay, let's start again. When you're dealing with beams and you're dealing with location, structural beams, if you want to drop this structural beam down, you can do it two ways. You can change the offset level, or you can change the z-offset value. In our office, it kind of depends on what we're doing, but typically, if it's floor framing, flat floor framing, we'll do the z value. If it's roof framing and the beams are different heights, then we'll do start and end offset. But do you see how that being lowered? Because you can either do that, does everyone say with me, or you can do -6 here, right, and -6 here. here's my warning to everyone, because as you get more involved with Dynamo, you're going to be extracting beam surfaces, and like a lot of times I'll put like channels on top of these beams, and I'll need to know the actual location. In this scenario, in this one, if you select the beam, just kind of a warning here, just so you know, because I got burned by this pretty hard. So if you select the actual beam element, like this one, okay, and the way you get this location is you go to, you don't say curve, you actually go to elements, and then under element you say beam, structural framing, and then you say location. If it gets curved geometry from location of specified structural element, okay, and it actually gives a curve. What the curve is, it's extracting is this curve right here. But just be aware, if you actually take this beam and offset it instead of using the offsets, if you use, instead of using the end offsets and you use the Z offset value, do you see how its work point line is still up here, what I call the blue wire, but the physical beam is down here. Dynamo is still reading the beam up here, so you're still going to see your Z value equals 0. See that?
Yeah.
Even though this beam has dropped down 6 inches. So it's something to be aware of. You could modify that by getting set parameters if you wanted to, but just be aware that when you're pulling framing location, it's pulling this blue line location, not the physical top of this beam.
Got it.
Got it. Okay, cool. Okay, I think that's a good place to end. Hope you learned a little bit today. I mean, I have about 20 topics I could cover, but of course I just wanted to talk about the quick, short, sweet ones. Maybe we'll do a part 2 one day, Cesar.
Yeah, but that will be in person, right?
Yes, in person.
Awesome.
Okay, thank you, everyone. I appreciate it, and thank you, Cesar.
Thank you very much, Marcello. We will.
Okay, you're welcome. I'll be signing off. I'll send you the data set, and if there's any follow-up questions, forward them to Cesar, and he'll get them to me, and we'll go from there.
Yeah.
Okay, thank you, everyone.
Send us the data set, and we will publish this in our YouTube channel.
Okay, great. Thank you.
Thank you. Bye, Marcello.
Bye.
Okay, bye.